Okay, everybody, my name is Patty Hagan, and I'm the Executive Director and President of T-Rex. If you don't know me, I think I pretty much know everybody here, though, so lucky for me, because what a great group of guests we have here today. What a great panel we have here today. I'll just say a couple words about T-Rex. T-Rex is a nonprofit innovation center focused on economic development to grow inclusive workforce, and entrepreneurship and innovation in St. Louis. So we have many of our sponsors here present today, and I'm going to kind of go around the room and kind of point some folks out. So if I'm missing anybody, just yell out to me. So we have Verizon, our friends from Verizon here, Mackenzie and Corey. And we have our friends from Purina. Mark Donovan is back there. Dick Fleming, one of our partners here in the region, in this downtown North Urban Insight District. And most importantly tonight, we have our partner, Riverside Research, who has a national presence, but now has taken a space here at T-Rex as well, and is partnering with us to build a lot of resources for the St. Louis community in terms of innovation and entrepreneurship. And I want to kind of call out our friends. So Todd Sherwood from Riverside, he put together this program today, and Carbonell. Where's Jeff? Jeff is around here somewhere. Jeff, there, you're sitting right in front there. Jeff Altman, all of our friends, thank you guys so much for doing this. We're just thrilled to have you put this series together for us. This is the first in a series that is focused on the Metaverse. And it's timely because the U.S. GIF conference that's coming up is going to be focused on Metaverse. Riverside was wise to think about having this kind of a series in advance of that conference. Other partners up here, ARS, we work really closely with them. Another reality studio, you're going to hear more from them. And of course, I'm going to introduce our moderator here today from Riverside, Dr. Bill Casebeer, who is the Riverside Research Director of AI and ML for the Open Innovation Center. So one more thing that I want to mention, this is also timely in that we are opening an extended reality lab here at T-Rex, and Riverside is working with us a little bit on that, but another reality studio is managing that for us. So lots of possibilities are starting to develop here around this kind of theme. So Dr. Bill, I'm going to turn it over to you, my friend. Thank you so much. Thanks for coming.
Thanks very much for the kind introduction, Patty. It's great to be in the T-Rex. What a beautiful facility you have. I think you're blessed to be in a lovely innovation center. It's my pleasure to introduce our two panelists today who will talk along with me about the implications of the metaverse for really everything that we do, but especially for the geospatial intelligence community. Our two speakers are, first of all, Brad Martin, the founder and CEO of Another Reality Studio. And Brad, I know, is a very well-known figure here at the T-Rex. We first had a conversation about probably a year ago after the last GeoInt conference, and are looking to cook up some collaborations using some of his VR and AR methods. It's also a pleasure to introduce our other speaker on the panel, Dr. Andrew Youkilis. He's the useful kind of doctor. Right, so the kind you want around. He does spinal surgery and stereotaxy for neurosurgery of St. Louis, and is uniquely innovating with his application of VR technology for surgery visualization. So we're going to be honored to hear from him today. So in order to set the stage for our panel, I'll take about 10 minutes or so to give a brief presentation, introducing the idea of moving from maps to the metaverse. I think in order to understand the implications of the metaverse for the way we do business in the geospatial intelligence community especially, we should probably think about how we change GeoInt one pixel at a time. And in order to do that, I will take speaker's privilege and tell you about Riverside Research Institute for a few moments. I'm sure there are lots of potential collaboration opportunities here, so I'll share with you what Riverside is and does. I have a couple of slides where I introduce the concept of the metaverse, So what is the metaverse? That helps ground our discussion of technology. Then third, since I know a lot of you here because of the geospatial intelligence focus of this panel, I want to talk about the potential impact of the metaverse on the PC-PED framework, that typical framework we use to structure thinking about intelligence activity, processing, planning, collection, processing, exploitation, and dissemination. I think that highlights a few opportunities we have for how we can use metaverse-centered technologies to optimize the PC-PED process. But of course, we do need to be aware of both the effects that we create as we build technology and the unanticipated effects of the metaverse. And I'll just end by highlighting some hope that all of you will help use the metaverse in unexpected ways to revolutionize how we do intelligence. So my sponsoring organization, Riverside Research, has existed since the 1960s. We spun out of Columbia University. We are a not 501c3, not-for-profit institution, chartered in the U.S. and its allies' national security interests. So our job is to bring teams of scientists and engineers together to tackle the nation's hardest problems in technology development and application for national security. So we have a variety of labs that do that work, a variety of business units that serve customers like the Defense Advanced Research Projects Agency, the National Geospatial Intelligence Agency, Intelligence Advanced Research Projects Activity, the service labs like Air Force Research Labs, and so on. So that means a lot of us are former military or government personnel. Many of us have security clearances. That's something to think about as we think about collaborations. And all of us are interested in applying the best of science and technology that we can to help make our nation and its allies more secure and safe. One piece of Riverside Research that I'm especially proud of is the one that Patty highlighted in her introductions. And it's such a pleasure to work with Ann, Jeff, Todd, and the Commercial Innovation Center team. So I know a lot of you have a geospatial intelligence focus. The CIC was chartered a couple of years ago to stand up a federated virtual environment where providers of data, analysts of data, and customers who need products coming out of the data can all join together in an IP-protected, easy-to-use space to do research and development in. So I think it's an awesome concept, and I would say that even if I were not employed by Riverside Research. And if you're interested in it, I hope that you'll go tackle Ann, Jeff, or Todd and ask about how you can be a part of it. And we're interested in joining together the community of people who serve our geospatial intelligence needs, ranging from those who provide the raw data all the way through to those who transition the analytic products coming out of that raw data into projects that work to improve our geospatial intelligence analysis processes. So please talk to Jeff or Ann to get more information about the Commercial Innovation Center and join with us in innovating inside of it. My particular organization in Riverside sidles up or sits next to the Commercial Innovation Center. So just so you have some context to understand why I talk the way I do, I lead a team of about 25 machine learning scientists and engineers. And what we try to do is we try to put the best of teamed human and machine intelligence on tap for the warfighter and the intelligence community analyst anytime and anywhere. And what I mean by anytime and anywhere is we do AI and ML at the edge where the sensor is. We do it back at the ground control station where multiple intelligence analysts, warfighters are interacting with those sensors that collect that data. And we do AI and ML back at the data lake where that data is deposited, mining it for continuous insight. We really do that by focusing on 4 different technologies. Object and activity recognition using machine learning. So all the buzzwords from machine learning, deep learning neural networks, recurrent networks, TensorFlow, PyTorch, all these tools we use day in and day out to find things in stuff. Multi-int fusion, if you will. Second, we port those algorithms, when they work, to neuromorphic substrates. Those are more brain-like forms of computation that lower latency, lower the amount of time it takes to do the computation, and lower the size, weight, and power requirements of the computation. And that's important to a lot of customers. Finally, we then use VR environments to both fill out big data sets that actually aren't big in the right ways. They're missing features, aren't labeled, aren't ground truthed, with synthetic data. That's one thing we do in those VR environments. And the other thing we do in those VR environments is we put our warfighter or our analyst into first contact with the algorithm. So we can do early stage development and testing and edge case testing and do things in the simulated world we may never be able to do in the real world. That highlights our final area, human-machine synergy. I have several cognitive scientists, neuroscientists, and human factors engineers who try to stitch together those technologies I just mentioned to build a prototype that actually improves the performance of the analyst machine team. Where do the buttons go? What color do I make them? How do I express uncertainty? What insight do I need into the operation of the algorithm? When should I introduce the output of this algorithm into workflow? Those are the kinds of questions they deal with. Perhaps more interestingly, they are also working on what we call cognitive state estimation algorithms. This gives our machine teammates, our algorithms, the eyes and the ears they need to understand when I, the human teammate, are losing situational awareness, or when I'm overly cognitively burdened and can't think of the next word to say. Anyhow, so these technology focus areas are things I love to talk about. What I'll do today is kind of apply them to the notion of the metaverse. So let me quickly move to what the metaverse is. I think the metaverse is many things to many people. Here's what I think of when I think of metaverse technologies. I think of a federated, multi-user virtual space. So a space where I can bring together multiple people and their algorithms, accomplishing multiple tasks in a distributed or federated environment. I think the metaverse is characterized by multiple modalities of interaction. We are so used to the keyboard and mouse combination that we forget that there are much more interesting ways of interacting with people, with data, and with computers. So think of virtual, augmented, or extended reality and some of those technologies. I think also there are multiple enabling technologies that help us stitch those two together, ranging from headsets for viewing a virtual space, through to the technologies we use to construct the virtual environment. I spoke with a couple of you about that earlier. Through to the sensors that are embedded in this equipment that measure something about me, from the inertial sensors that help me position myself in the virtual environment, through to the eye trackers that let the VR world, if you will, know where I am placing my eyes so I can control something or so that it can understand something about me. And I think eventually, as the technology hits the market, we'll see yet more devices that incorporate things like electroencephalograms, heart rate monitors, galvanic skin response, advanced pupillometry, not just gross eye tracking, all of which can be used to tell us more about the human user of a metaverse technology. And since I'm a sci-fi fan, I will just say I've been, dreaming of implementing the metaverse for things like intelligence work since I read Neil Stephenson's novel Snow Crash, which maybe some of you are familiar with. One of the first popular science fiction implementations of the metaverse, with Snow Crash being the idea that when you disable a metaverse environment, you get that snow-like effect that you see on an old-fashioned tube TV when you turn it off. All the way up to Meta and lots of other companies that are making, quite literally, billions of dollars of investment into metaverse technology. So Snow Crash to Meta. And it is really the frontier days here. I'm grateful to Todd, mentioned earlier, for his work in putting this slide together. Not only does it highlight some of the affiliated technologies and concepts that you see when people talk about the metaverse, it also highlights a lot of the companies that are invested in building out technologies in this space, such as Meta. All right, in my last 5 minutes or so here, let me move quickly now to thinking about the implications of these technologies for intelligence. So one framework we can use to structure our thinking here is what's called the PCPED framework. That is the idea that to serve any particular mission need, you are going to have to, first of all, plan an intelligence collection event. You're going to have to collect the intelligence. You're going to have to process that intelligence somehow. You're then going to have to exploit it or analyze it to come up with something meaningful. And then finally disseminate the results of that analytic or exploitative process to a user. So, of course, there are other intelligence activities that may not fit neatly in this framework, and you can make a lot of hay if you Google the PCPED framework in attacking it and saying it doesn't accurately characterize the way 21st century intelligence is done. I don't want to get into those night fights. I just want to say this is a good place to start conversations about how the metaverse could impact intelligence. So some possibilities here on the planning side. Currently, a lot of our planning processes are at least semi-automated, right? You ingest some intelligence collection requirement, hopefully a priority one. You have a set of algorithms that work over those analytic collection requirements and match them to sensors and systems and then coordinate the activity of that system. What if we were able to visualize the impact of collection planning on collection outcomes more easily? Right now, honestly, that's difficult to do. I think a metaverse environment will allow us to easily do that. And the really interesting thing about that is it will let us use analyst heuristics and biases, the way our brain takes shortcuts to make sense of data, to our advantage to actually plan more efficiently. That's where I'll spend most of my time of my remaining 3 or so minutes talking. I think also, though, we can use Metaverse to help with collection by involving analyst judgment in dynamic retasking. So helping, for example, bring the human who put the priority intelligence requirement into the system in the first place into the loop as the collection event is taking place so that they can provide guidance on dynamic retasking. Something very difficult to do presently, I think could be enabled with the Metaverse. Same for processing. I think a lot of our multi-int fusion techniques that will let us process data effectively and get it into a closed loop with itself so you can optimize collection reaching back has to take place at the edge. And that will improve priority requirement satisfaction, I think, and the Metaverse can assist there, I believe. I also see, since I spent most of my time in the intelligence trenches doing analysis, lots of opportunities for multi-analyst, persistent analytic environments that the Metaverse could support. We have a dark chip project going in my lab at Riverside Research where we collaborate with the Commercial Innovation Center to fuse together multiple types of data to tell whether or not a ship is trying to intentionally avoid detection, maybe because it's smuggling people or carrying drugs or doing something nefarious, busting a sanction. And I think there are opportunities for us to create Metaverse models of ships where metadata is tagged to all the sources of intelligence that might indicate what activity that ship is carrying out and why, so that you can look at it from a different angle, maybe reach a creative and rapid solution to the dark ship problem. Finally, dissemination, lots of opportunities to give intelligence consumers new products in new ways. Think about the president's daily brief. How does the president get the briefing now? It's printed out on paper. They may, if they're lucky, have a verbal briefer. There might be some photographs affiliated with that. That's about it. We need to change that. We can do that with the Metaverse. All right, let's drill down now, and then I'll exit stage right, into the idea of how the Metaverse might impact how our brains process data. Here's a eye chart, meaning you can't read it. It's heuristics and biases list. There are hundreds of them on here. They're grouped into the shortcuts our minds and brains take as we try to either make sense of an overload of information, try to think about what is important to remember when I'm deciding what to do, whether we're trying to act fast in the face of that information, or when there's a sparsity of meaning in the information. Those are the 4 general classes of heuristics. So, you know, a heuristic that says, what should I bother to remember, is the recall heuristic. So that's the idea that I should probably bother to remember those things that are easily rememberable. Makes a lot of sense. But guess what? If I ask you which kills more people, terrorism or a honeybee sting, you're probably much more likely to remember a terrorist attack like 9/11 than you are to remember that you were stung by a bee 364 days ago, right? You just don't recall that unless you have an anaphylactic shock issue, but we'll take that offline. So in those cases, you'll probably be led astray by your recall heuristic because it turns out bees kill many more people each year than terrorists do. Because of anaphylactic shock. So heuristics can be adaptive, they can be good, they can be bad. We want to make sure in our intelligence PCPED process we leverage the heuristics in the right way so they truly are adaptive. Here's a way we might do that. We have the tendency to discount expected future returns. If we do that dramatically enough, then we will fail to save for retirement. That's the insight of the prospect theory heuristic. How can we overcome that? Well, a couple of ways we can do that. We can provide a person with a Metaverse experience where they see the impact of their choice. So my friend and colleague Jeremy Bailenson did some really interesting work where he showed that if I make visceral the effect of the consumption of paper judgment on cutting down a tree, that people actually moderate their use of paper products outside of the virtual environment. right? Secondly, think about the idea of saving for retirement. My, future self, I mean, I'm getting a little bit closer to having more bald spots, so, maybe this doesn't apply to me, but saving for 30 years from now is not on my time horizon, right? But if I could virtually age myself and put that age version of myself in front of me in a metaverse world and interact with it, there are several labs that have evidence that this actually causes me to correct for my tendency to not want to save for the future, that prospect theory bias that I have to overweight rapid and immediate returns. So really interesting insights into how VR and AR can impact PCPED in the metaverse. If you come by our booth, if you did last year at GeoEnt, you saw a planning demo where in VR we showed how planning choices can cause analysts to not be able to understand what happens when they neglect secondary or tertiary targets that are of critical importance. And a VR experience can make that relevant so they can make a dynamic choice to reassign the priority of a target, which helps us in the intelligence world. Another way you can do this is think about multi-int collection and trying to figure out, say, the shape of an object on orbit. Maybe you only have some limited radar returns from that object on orbit, and you need to fill it out with synthetic data and with a set of tools that you manipulate in 3 dimensions in the metaverse so you can assess the judgment that you're making about the morphology of that satellite. I don't know if it's collecting against me, for instance. So this is actual data from a synthetic data sphere that we generated from limited radar returns that we put together for Air Force Research Labs, trying to bottom out in a model, a CAD model, of the satellite. I would love to do this process in a metaverse and not on a desktop. All of that finally connects to that idea of discovering dark ships via a multi-int fusion process. I'm not going to walk you through that diagram on the right, but suffice it to say that if I could merge my multiple types of data into a single analytic environment, I could probably make rapid breakthroughs in fusing together data in the best way that my 10 to the 14th neurons with 10 to the 15th connections can do, leverage the unique power of the human brain. Now, I anticipate that there will be much more interesting uses of the metaverse than the ones I've outlined for PCPED. The biggest effects will likely be unanticipated, honestly. That is the nature of technology. But as the former director of DARPA, Regina Dugan, used to put it, when I worked there, she said, "Bill, the best way to predict the future is to create it." So I'm honored to be in front of a crowd of innovators who are going to be creating the technologies that push intelligence analysis into the universe of the metaverse. I look forward also, of course, to hearing more from our next 2 panelists about that process. So let me go ahead then and say thank you and turn things over to Andy to think about a practical, maybe a more practical application of VR.
Thank you so much for inviting me to be here tonight. I'm usually considered the geek in the room, but I think I've been outclassed tenfold. My name is Andy Youkilis. I'm a neurosurgeon. I work at Neurosurgery of St. Louis. We work out of, closer? Okay. Yeah, my name is Andy Youkilis. I'm a neurosurgeon at Neurosurgery of St. Louis. We work out of the BJC network at Barnes hospitals like Missouri Baptist. We also work at St. Luke's Hospital. My particular field is a functional neurosurgeon. Like I said, amongst my peers, I'm the geekiest of the geeks. Functional neurosurgeons are neurosurgeons that deal with neuromodulation. How do we impact the nervous system in such a way to create a positive benefit, eliminate pain, stop seizures, eliminate tremor, change the nervous system in a positive way to impact a patient's life. Our field is on the cusp of a huge wave of innovation. Technology now has taken us to a point where we are in the metaverse doing things virtually before we're doing them physically. And this allows for so many different and unexpected benefits. Big data has impacted medicine in a way that is incalculable right now. We now are able to look at the end and understand the beginning. So one of my teachers, Dr. Julian Hoff, who's since passed, would always start an operation, start with the end in mind. Well, really, that's where we are. We are looking backwards. We're taking data from the end in neuro-oncology and understanding which patients, because of big data, respond to which chemotherapies, which patients are better responders to surgery. So we're taking big data, putting it in the metaverse, and going backwards with machine learning and understanding which patients are better treated with which technologies. Just a practical implication that I'm going to get to, but in scoliosis surgery, we used to bend the rod to the patient. Well, now we do the surgery virtually, and we bend we used to bend the rod intraoperatively. Now we bend it preoperatively. So that rod is created by a machine that is individualized to a patient. And so I'm going to start with the end. This is the culmination of where I am right now. The picture on the right is a virtually created stereotactic frame, and I'll try to explain these words for those who don't understand them. A virtually created stereotactic frame made by a computer in a 3D printer that takes the target of my surgery, which I'll explain, and the entry point, and puts all of this data into a very simple three-dimensional stereotactic frame that allows me to aim at a target so I can achieve my goal. So on the right is the end, on the left is the beginning. It's a data set. It's an MRI taken with a side view, if you will. We call it sagittal, looking at the internal landmarks of the brain. And those two landmarks that are on that line are amongst all of us within 1 millimeter of a difference. The line between those 2 points is 24 millimeters, plus or minus a millimeter, in every single person in this room. Very reproducible internal landmarks. So how do we get from the external to the internal, and how do we get from A to B? And so I titled this "Navigating the Globe," because we do navigate essentially a volume. This is from the 1940s. These were the first stereotactic frames. And essentially, to navigate any volume, we have to have a three-dimensional space that's defined. We can define it with Cartesian coordinates, x, y, and z. We can define it with polar coordinates. And different stereotactic frames define volumes using these different systems. This is, of course, from the 50s, before we had any imaging. We were using X-rays with dye injected into the spinal fluid. Stereotaxy means image guidance. It really means three-dimensional touch. Okay, and surgeons in all fields now are using stereotaxy. We obtain a data set. It can be an MRI, it can be a CAT scan, it can be a PET scan. We merge these data sets for fidelity. And then we utilize reference points to merge the intraoperative anatomy with the preoperative anatomy. And so that, we can then navigate in three-dimensional space. And this is the Lexell frame created by Lars Lexell, with probably the father of stereotaxy, a Swedish neurosurgeon, who made a very simple observation that we can define any spot within the brain using a reference frame, in this case a box that is screwed to a head, and X, Y, and Z, any space, any point within that three-dimensional space, we can then access. And so this is what's called frame-based stereotaxy. And this is where I trained when I started stereotaxy back in 1996 in my training, learning about it. This is where we are now. Instead of a realistic frame, we use a virtual frame. These are skull-based fiducials implanted in a patient's skull. You can see the three-dimensional representation of the skull. And you can see these tiny little screws that I've implanted in the patient. And those screws now are my satellites, if you will, that are embedded in a three-dimensional volume that I can then use a computer to navigate with. And in this particular case, I'm creating that frame that I showed you in the first place in a patient with a disease called essential tremor, which is a disabling tremor that stops people from feeding themselves, stops people from writing. It's also used for diseases such as Parkinson's disease and dystonia and depression and seizures. Neuromodulation is at the forefront right now of what we do in neurosurgery. So to take this back to reality, I wanted to try to compare, and I'd like to thank Adam. Adam's here somewhere. Oh, right there. Adam Simmons, right? Adam and I had a great talk on Monday. There's going to be a podcast that involves a lot of these topics. But this forced me to think about, how is my life similar to your life? Because what I do is very different from what the geospatial agency or industry does, but the synergies are incredible. So the similarities. We both want to define a three-dimensional volume. We want to know what's inside that volume. So to do so, we require landmarks. In my field, we have external landmarks and internal landmarks in the volume. In your field, the internal landmarks are not that trustable because they move. The surface of the Earth moves. The magnetic field of the Earth moves. And so my accuracy is micrometric. So I can reliably reach a target with micrometric accuracy. That's probably something that the geospatial industry is interested in. Yours, I'm sure, is very accurate, but the difference between the subthalamic nucleus and the zona incerta is submillimetric. And if I hit one target versus the other, it's the difference between a good outcome and a bad outcome. So we require landmarks. Our accuracy, I would say, is probably a little better than yours because our volume is smaller, but our data sets both need to be updated. We have multiple types of data, and overlapping those types of data increases our accuracy. So it can be visual, it can be energy, it can be electrical, it can be infrared. But both of our systems are really focused at one thing, getting from point A to point B. That's it. So our differences, and this is, I've just started thinking about these things in the past several weeks since Todd introduced the topic. Stereotactic targets are relatively fixed. We don't have people moving inside our head. Of course, we have blood flowing and we have, electrons flowing, but our targets are relatively fixed. GPS targets are both fixed and mobile, and you guys have to take that into account. Stereotactic data sets right now are mostly image-based, but in the future, we're going to be having, because of our knowledge of neural networks, and because of our knowledge of the overlaps of data sets, we're going to be having sensors, both passive and active, that give us real-time data. One of the computer systems that I use now uses LiDAR to track the spine. So I can know with a very high degree of certainty, not just using a point in time, but using real-time data where things are. Geospatial intelligence uses multiple types of sensors, probably a lot more than we do. So we need to learn a lot from you because these sensors are getting smaller and smaller, and very soon they'll be implantable. We use internal landmarks which have higher accuracy, and there are really no fixed internal references inside the Earth from what I've been made aware yet. But where we're at now is using the metaverse to make customized implants, using the metaverse to figure out where we want to go, and then designing the path to get there. So taking the end first and designing the way to get there. It's not starting out in a trip and hoping we get in the right spot. It's knowing where we want to be and designing the way to get there. So this is a picture of our internal data sets. These are those points that I was talking to you about before. I won't go into too much depth. This is an anatomic representation of those points, which are called the AC and the PC, which are the cross commissures, white matter tracts, what's inside the brain, which are, like our pupils, from one person to another, almost within a range, almost exactly the same. These are within a millimeter of one another and helps us to define different points inside our volumes. The picture on the left is the representation of these points. Now our data sets are getting so complex and so accurate that we can use a 7 Tesla MRI and see our targets and target directly. Using those fixed landmarks, we use indirect targeting, but now with the fidelity of our data sets being so much richer and so much more accurate, we can directly target. So the little circle, the black circle, is the red nucleus, which is about the size of the tip of my pinky. And the black angle is my target for Parkinson's disease, which is the subthalamic nucleus. It's about 4 millimeters in greatest axial diameter. It's tiny. But I need to put my probe right down the middle of that 4 millimeter almond to achieve the effect, which is elimination of tremor, rigidity, allowing a person to walk better, and alleviating a lot of the symptoms of Parkinson's disease. So this is direct targeting. I wanted to show you the accuracy of our database. This is a post-operative MRI scan merged to a preoperative data set. The green line in the middle of the white electrode was my plan. That's where I wanted to put this. I don't know if you can see it. That's where I wanted to put this electrode. And merging my post-operative data set to my preoperative plan, that's where I put it. That's the accuracy of what we can do inside the brain now with a very simple targeting mechanism. This is the computer in surgery, allowing us to image guide looking outside of the head with a probe that's being read by an infrared sensor that's bouncing light off of my probe. And it's allowing me to look at where I want to be so that I can avoid the optic nerve on the way to the tumor. I can stay out of the blood vessels on my way to the target. And so all of these things are crucial. This is a data set, an intraoperative data set, which is called microelectrode recording. Each of our deep brain nuclei have specific electrical patterns, and these electrical patterns can be differentiated. I'm not sure I can actually play the sound here. Let's see if sound is hooked up. No, never mind. So suffice it to say that it's not just visual data sets that I'm using, it's electrical data sets that I'm merging back and saying, okay, I know when I'm in the target, I know when I'm out of the target. And that can give me increased confidence that I am where I think I am. The future of navigation for us is real-time data acquisition. That's going to be from microsensors, implantable sensors, implantable sensors for real-time information, both active and passive, using machine-based learning and augmented reality to do the operation virtually before we do it physically. Right now we are virtually creating implants that are customized. So for example, Gabby Gifford's skull defect after she was shot was created in the Metaverse. That was a customized implant made from a data set that mirrored the other side, and that customized implant created in the Metaverse was brought back into the universe and put inside a human's body. That's what we do now. Augmented reality, we're just on the forefront of this, mostly for learning, mostly for neuroanatomy for medical students and for residents, so they can do the operation virtually before they do it and put someone's life at risk. And finally, the brain-machine interface. That's where we're at. A researcher, a friend of mine here in St. Louis, has created an exoskeleton using stereotaxy to implant a grid on a person's brain that they can then control that exoskeleton so someone's paralyzed arm can now move. The possibilities are endless. One of my favorite sayings is, a fool with a tool is still a fool, right? And I think this was created by a neurosurgeon. It certainly is very fitting. But all of this technology, if not applied properly, can still lead to dire consequences. In my case, death, disability. In your case, friendly fire, inaccuracy. But a fool with a tool is still a fool. And finally, this is my last slide. Last week, my wife and I were in Yellowknife, Northwest Territories, watching the aurora borealis. The amount of data that was at our disposition to see these incredible energy bursts from you was amazing. We could tell when the weather was going to be right. We knew when the energy was there. We could go accurately to the right spot and see this incredible scene. And all of this comes from standing on the shoulders of giants, being able to take what was given us and take one step further. That's what you've given to us, and that's what we're giving to you. And I think we have a lot to learn from each other. So that's the end of my presentation.
I thought my job was stressful, and then I'm like, Andy's talking about getting inside people's brains. But we do that just on a different level. which is what I'll talk about today. So it's kind of funny too, because out of all three of us, you'll hear like our descriptions of the metaverse, right? And you'll hear like, oh, it's for visualization, it's for data collection. Then you'll hear somebody else, oh, it's for design, it's for 3D printing. And then I'm here to tell you, oh, it's this experiential thing. And it's like, how can it be all these things? I think I speak more in analogies to try and help understanding. So just the kind of the best phrase that I can think about is like a car. Like if you were to ask somebody what a car does, somebody's gonna be like, oh, it gets you to point A to B. And somebody else is gonna say, actually, it's for like going as fast as you can down a straight line and seeing what your score is. And then somebody else is gonna be like, no, I like to drive around the dunes and do, donuts. So there's this vessel that can do many different things, and that is different to each person, but it's still a car. And I think all of us are talking about even more detail a part of that car. So we'll talk about like where mine, we may be inventing the wheel that can then be a part of this car. And we're all kind of designing these different portions that make up, they're functional in and of themselves, but they make up this bigger, better thing that can then be used for everything. So as we're talking about the metaverse, you'll hear a lot of these things that talk about all of these technologies, all of these industries kind of converging into this metaverse that then allows you to have more data, more information, and therefore make every industry grow exponentially. So think of it in that frame set as I'm talking. I'll talk a lot more about tool sets and ways of developing items that could be kind of deemed as a part of the metaverse. But first I'll give a quick introduction of who I am. So my name is Brad Martin. I founded a company called Another Reality Studio for augmented and virtual reality development in 2013 with a co-founder, Mauricio Espin, who does more of the actual smart stuff, the technology. I'm more of just the dreamer, and he makes it all happen. So this is a quick slide deck of some of the stuff that we do. So I won't, this is our pitch deck to talk to a lot of people who maybe don't know as much of the technology as you guys do. So I'll fly through this really quick, but there's many different ways to distribute AR and VR, or augmented reality and virtual reality applications. Some of them, in a more basic form, are just 360 images that you can collect fairly easily and then put into a headset and be able to turn around and kind of look around. Others are a lot more involved where in virtual reality, you're putting on some sort of wearable and you are fully immersed into a virtual space. So you're fully into a virtual world. Whereas in augmented reality, you're using some sort of screen. It could be a headset, which can be confusing, but it's also more so like an iPad or an iPhone. And you're bringing a virtual element into the real world. So you're visualizing something overlaid into the real world. So you're augmenting it. And then finally, a mixed reality. If you weren't confused enough already, we can use a term called mixed reality, which is essentially what you're starting to see, which is this merging of augmented and virtual items together and interacting with the real world. So hence the metaverse. When you can do something in a digital space and it does something in the real world, or it relates to the real world from a data standpoint. So you'll see some of those terms here as we go through. So we use this technology in many different industries, and I've kind of thrown something together here that talks about training, education, geospatial technologies. Everything can be informed and used in AR and VR in every industry. So you'll see some of the points here of different things that we've done. In fact, with T-Rex, we partnered with them actually 2 GeoInts ago, whenever it was here in St. Louis, to create down here a 3D GIS map that is in augmented reality. And so you can actually view it on a tabletop and interact with different buildings to learn about them, or different companies to learn about what they do and where they're located. Also, we did a walking tour, which is a really cool way to use augmented reality, from this building over to the Globe building, and we were able to demonstrate location-based augmented reality. So not only is there augmented reality where you can visualize a virtual element in the real world, but there's many ways that you can enact that to happen. Sometimes it's based on your geospatial location. If you know your coordinates and you have your device, we can call something down in that spot. Other times it's via computer vision, machine learning, image recognition, all the terms that were underneath the umbrella of Metaverse. So tons of different ways that you can use these types of technologies. As we go through, I'll skip that one. That's just consulting, some services that we do. We have a team of almost 30 people that are software developers, but we develop specifically in Unreal Engine, Unity, different languages that correlate with those programs to build out these technologies. So kind of show some of the teams, but really our goal as a company is to meet with other companies, introduce them to the technologies, understand their pain points, and then merge them all together in some sort of a solution. So as you have a data collector and a way that wants to bring all these companies together from a data standpoint, we'll take that and then do something with it visually, something that could relate to the medical field, so that then Andy has his way of making sure that his operations go as smoothly as possible. So we all work together in these industries. So speaking of the GeoEnt virtual tour, this was the augmented reality experience at the T-Rex building. You'll see in the iPad we have Tina, the T-Rex, standing in the parking lot, and people are cowering beneath her power on this iPad. But it's a way to show that based on that location, we're able to drop a animated T-Rex in that spot. But we can use this technology for a lot of ways. It's a way to bring a space to people instead of people to a space. So in this other one, you'll see a virtual art gallery. You're able to walk through a portal anywhere that you're at into a specific art gallery and kind of view that installation. We also use it for training. This is actually a pretty important one recently, which converges a lot on this data that we're talking about. We want to help dangerous jobs become less dangerous. And the way that you can do that is by training somebody or informing them the best way possible. And virtual reality, where they are fully immersed into a virtual world, we can simulate these edge cases, these dangerous jobs, things that you don't want to happen and you can't really train on because you don't want them to happen. You can do in virtual reality by simulating it through synthetic data, through real life data, reenacting some things that have happened. And you can make sure that next time this happens, they know what to do or how to prevent that from happening. So virtual reality is extremely key in dangerous job training and helping that solution, because you can give them a full picture in scale and feeling. Literal feeling. There are devices that allow you to feel virtual elements. Pretty cool. We have some upstairs. Shameless tag, but upstairs, 7th floor. Be there. I can't read sideways, so I'm not exactly sure what we're looking at. Oh, conferences and training. Okay, so another way to do this is you can have events and conferences all in a virtual space, but still be present there. So we actually have held 1,000-person conferences where everybody's joining in virtual reality or on their desktop, just going to the website, and then they have an avatar that depicts them, and they can actually walk around, click on each other, which allows you to chat with them or video call with them and kind of experience the entire event together. But if you can't travel or if there's a pandemic, who would think that there'd be a pandemic? But if there were, just randomly there was a pandemic, you could use a tool like this to still go through conferences and events. Skip that, sorry. Some of this is a pitch deck. And actually, I'm gonna fly through some of this too, but you can also use it for architecture. We use it for design process, kind of like we were talking about before. So what's great about Metaverse and its technology underneath it is that there's no specific device that's required for it. You can actually use it on your phone, you could use it on the desktop, you could use it VR, AR that we're talking about, or it could be something that's living up in the cloud, like all of this data that Riverside Research is gathering for us to utilize. It's all stored somewhere, and then you can access it somehow and do something with it. So this is just a depiction of some of the architectural products that we were able to produce, which then gets into measurements, collision detection, so we make sure MEP is working together, not against each other, so whenever they're on site, it goes smoothly, etc. But it also gives the end user a way of visualizing what they're about to get instead of just this automatic trust that had to come with the designer, which is a good thing, but now you can trust but verify. So I'll fly through this, but the reason that it's a game changer, so I think this is important to talk about, all of this technology underneath that umbrella of Metaverse, the reason why it's so important is because now we can all use each other's research, use each other's data for the benefit of every industry and every job. So although what we're working on might not be directly related to brain surgery, a lot of the algorithms and things that we use that's creating some data will directly benefit the functionalities and the minute details that's required for Andy on his surgeries and what he's doing with these devices. So this is a technology. The reason why people are so excited about it is it's a technology that can really take it to an exponential growth across any industry and any job and job type. So that's just a quick introduction, and I'm looking forward to the conversations that we're about to have. So thank you.
All right, thank you very much, Brad. Fantastic. All right, let me seed the panel conversation with the first question, and then we'll turn things over to the audience. So, yeah, two fantastic presentations, a lot of really innovative technologies underneath the hood from both of you. My question for the panelists is, are there one or two technological barriers that are keeping metaverse technologies from being more widely used in your industry, and what are those barriers?
So, yeah, I think Brad touched on a very important topic, is that, the interface between the metaverse and the actual human brain is rapidly developing. The idea that we can experience, not just in one sense, but in multiple senses, the metaverse is going to be the barrier that limits us from playing a game to actually being somewhere. I mean, to be conscious, awake, alert, involves all of our senses. And so all of those senses will eventually be enveloped into the metaverse. But of course, we have much more than just five senses. Things like intuition, things like anticipation. These are things that we've not yet defined in neuroscience. We don't even understand memory yet, right? Memory seems to be in multiple areas of the brain. Our neural networks are not, as we learned early on, that movement is a frontal lobe function and sensation is a parietal lobe function. And well, it turns out that smell and touch and memory and taste are all over the place. And so as we understand that better, we'll be able to have a conversation that will allow us to have multiple senses delivered, probably through some sort of interface, whether it be a hat. I mean, right now, through transcranial stimulation, I can make someone's arm move by giving them stimulation. I can tell whether or not I'm injuring the spinal cord by doing somatosensory evoked potentials. These things, visual evoked potentials, I can see things that my consciousness is not seeing. I can look outside of my frame of reference and have peripheral vision, not just for visual sense, but reflexes. I'm very interested to see how augmented reality and virtual reality deals with input that is not conscious, because subconscious input is crucial. As I'm sitting here, I'm not falling off my chair because my vestibular system is telling me where level is, right? I'm not conscious to that, but how do you translate that into virtual reality? All of these senses will eventually be getting us closer to a real sense of reality, but I think we're light years away from that. Right now, it's a game, but eventually, as we understand senses and how both the conscious and unconscious, the sympathetic nervous system. Has anyone looked at? And I'll give you a chance to speak. But all of these parts of our reaction to reality have to be taken into consideration. Fear. How do you put fear into virtual reality? When you're expecting the visual to bring it on, but honestly, seeing a knife coming from outside of my perspective is going to bring on subconscious fear. How do you simulate that? There are things that I'm experiencing right now that I'll only be able to bring into my full human experience in sleep. There's too much input right now coming into my brain. Dreams are there for a reason, because the subconscious is receiving so much more information than the conscious brain is appreciating, that we put all that together and when we sleep. And so, yeah, with that, I'll try to let you respond.
Yeah, that is really interesting. It's a lot of things that I haven't considered in this, like as a barrier. I'm thinking like more direct barriers of metaverse, and I love that you're like thinking about some of like the physical. That's why I like talking to people in different industries, because you're thinking about like the physical limitations and barriers of this technology. To think about on the other side, like some of the technical barriers or some of the barriers from a cultural standpoint. I think two of the barriers that are actively being solved by people in this room. Number one, Riverside Research, like offering up data that allows people to do something with that data. Data, it takes time to collect, lots of time to collect. It also is extremely massive from a memory and storage, or can be extremely massive from a memory storage space. So having a data lake where you can go and not have to reinvent all of this data is a huge barrier that companies are solving, like Riverside Research. That's one that I think is still a barrier, but has some solutions on the outlook. The other one is what T-Rex is doing with the. This is not a shameless, well, it kind of is, but with the lab upstairs, education, like trying to teach communities, trying to teach companies how to use this technology. A lot of times, like people right now, we're defining the metaverse up here because it's an undefined term, because people don't know what it is, because they don't know how to use it, et cetera. So a community engagement, community outreach, community education on the topic and how they can use it is still a barrier, but there are things that are coming into place that are helping that. From a technical side, there are definitely limitations. There's a lot of stuff that's still being figured out. I mean, we're still figuring out Wi-Fi. I mean, there's things that we're still figuring out that are always going to push this technology further and further. So this is a infant in its the way that it's being developed, and I think it should be like that because we want to plan how to use it properly. We want to make sure that we're doing things appropriately, and then it does give way for other technologies to be developed, like generative AI. That's going to help the metaverse. That's going to help some of the developments that we're doing. And all of that is also extremely important to, again, think through, plan through, make sure we do it correctly. So outside of those more obvious barriers, like funding and funding the R&D and getting these demos up and running, I'd say the more less obvious ones are just perfecting the technologies that all build up the metaverse as a whole. I'd say that would be the thing that we should focus on. So.
Fantastic, thank you. All right, let me see what questions we have from the audience. Ann, I'll come to you just because you're closer.
I'm just going to ask, after thinking about the medical field and then the kind of virtual reality field you have, do we think that someday, like for the blind, we could create a maybe they can't optically see again, but maybe there's a way to tap the senses where they can use a metaverse, and maybe it's the difference between half consciousness and consciousness, where, I mean, you're in your dreams, you see stuff, you go through things. Is there something in the brain that could be tapped to use the metaverse to help them visualize what they can't physically see?
So we are presently already, I don't want to say beyond that, but if you look at the cochlear implant, for example, it's a sound generating device that bypasses the sensor. So the sensor in the hearing pathway, of course, is the ear. That involves sound waves hitting a tympanic membrane that's then translated through 3 bones and then stimulates this thing called the cochlea. Well, we've already bypass that sensor with a cochlear implant. That cochlear implant is sending electric data into the cochlear nucleus, which is then interpreted by the medial temporal lobe as sound, right? And people with cochlear implants are getting input, and they have to train themselves to understand what that means. That means me, or, So yes, visually, cortical stimulation now, we can take a sensor that's not an eye and give people with stimulation of the occipital lobe light perception. Eventually, those sensors will be good enough that it can be refined. The signal-to-noise ratio will be increased such that we can see clear images. Yes, I believe in my lifetime we will have implantable sensors that will make the blind see. The iterative development of that will make it better and better. Right now, initially it was just hearing unintelligible sounds. Now the cochlear implant has understood sound waves enough to help the brain interpret. So yes, we're there in some fields, particularly in the so we talk about afferent pathways, which are the pathways that bring sensation into the central nervous system. And then the efferent pathways are the ones that are the output tracks: motor, speech, sympathetic nervous system, We are much better in the afferent right now for sensation, but really it's afferent and efferent. And then, of course, it's modulating all of the things that go between that. You know, input and output is bridged by a huge gap of consciousness and understanding and memory and recall. But yes, we are there now in some of the sensory pathways, and I think we'll be there in a much greater sense within the next 10 to 20 years.
I'm not qualified to answer this question.
I'm going to stay on the medical arena as well. First of all, thank you for a terrific panel. As Patty indicated, T-Rex and the Globe and Square have worked together in creating this new innovation district, and one of its newest members may be in the stereotactic field. Andrew may be familiar with them, stereotaxis, which for heart surgery they've grown from a startup at the Center for Emerging Technologies to the first tenant at Cortex to now a major tenant down in this district, and have become in heart surgery a global leader. How does what they do parallel what you described in terms of the application to brain surgery?
So, you know, the heart is an organ that has its own electrical system. So there is a field of electrophysiology, EP cardiologists, who understand the intrinsic electrical pathways of the heart to a degree that is mind-boggling. You know, there are nodes in the heart that will automatically make the heart beat even when it's outside the body. The SA node gives an electrical signal that goes down to the AV node that makes the heart beat in a reproducible pattern. And the electrical connection of the heart is understood to such a degree, it's really incredible. The implantable sensors that our cardiology colleagues have right now are enviable to us, because they can take a tiny little microchip and implant it under the skin, and that little microchip can tell your Wi-Fi at home when you're having an event and alert your doctor before you even know it. Incredible. That kind of sense technology exists for the heart because they are light years ahead of us, understanding the electrical pathway. And this is not at offense to them, because it's a very simple electrical pathway. It's one, right? There is an automatic electrical pathway in the heart, and they understand it to a degree that is very enviable. We don't have those sensors. We don't have, and I wanted to get to the first question. One of the big barriers for us is size. Not to be critical, but if you look at the size of those goggles, those things are going to get smaller and smaller and smaller, right? And their battery power, it's also a limitation. It's going to get longer and longer and longer. The internal pulse generator that I first put in for deep brain stimulation had a 2-year life. Now it's rechargeable. It's 15 years and going. And so not only that, but the sense technology in our implantables now has feedback loops. So what is inside the chest can read what's going on in the brain, can automatically modulate and change itself based on a software algorithm. It's incredible. We now have directable current, where this electrical implanted lead can guide itself to the target based on certain brain waves. That's just going to get better and better and better. But cardiology is light years ahead of us because the electrical system is completely understood. They know to the nth degree where all of those neurons run. I'm sure that they have a lot more funding than we do, and that they're using virtual reality. We use virtual reality right now. We have 3D glasses that we put on instead of using a stereoscopic microscope. A stereoscopic microscope was invented in the 1980s, was a leap year advance for us. We now see things in 3-dimensional space better than our eye can see. A stereoscopic microscope is, the first time you look inside of it, you think to yourself, oh my God, how beautiful. Because you're seeing better than you can see with the naked eye. When you see a cranial nerve surrounded by arachnoids, surrounded by micro blood vessels, for someone like me, it's like, oh my God, this is so beautiful. When you see a spinal cord tumor pushing the spinal cord away in three-dimensional space with the blood vessels coming up and going away, unbelievable. And so eventually we'll have better ways of seeing, because we already can see better than the human eye, but we're just at the forefront. We can use it for training. Right now there are some three-dimensional monitors that are a little bit better than a microscope, but operating here where the substrate is here is a tough thing to learn. So we're getting there. I'm pretty wordy, I'm sorry, about the long-winded answers.
I have questions for both of you, so I'll start with the medical. So my son has Asperger's. Do you see where this can target into people like him who has a condition that we don't know what causes it, and then epilepsy and Parkinson's? Are we going to be able to start to cure those sorts of conditions with this technology? Because when I looked at what you were pointing to, I was blown away. I mean, I would love to learn more about what you guys are doing.
So neuropsychiatry is a field that has existed for a long time. One of the more common off-label uses of deep brain stimulation is obsessive compulsive disorder, OCD, and now it is an acceptable treatment for that. I participated in a study for epilepsy called the Sante study, the stimulation of the anterior nucleus of the thalamus for epilepsy. There's a circuit within our brain called the Papes circuit, which goes from the thalamus through the structure called the fornix to the anterior nucleus of the thalamus. And in dog studies, someone understood you stimulate that in dogs who are given seizures, and you can decrease their seizures. So yes, vagal nerve stimulation now is a on-label treatment for medically refractory epilepsy. Implantation in the anterior nucleus of the thalamus is a implantable target for OCD. I'm sure very soon there will be a target for Asperger's syndrome.
And how much work is Barnes Jewish Children's doing in this area?
A ton. So I'm a worker bee. I'm a miner. I'm a coal miner. I'm the one out in the trenches. I'm not the guy doing the research, but I am good friends with those who are. And interestingly, the developments that are coming are WashU is a huge source of them. The man who is associated with the brain-machine interface is this neurosurgeon Eric Luthart, who was a medical student who lived at our house in Ann Arbor when I was training. So yes, St. Louis is a center for development. Albert Kim, who's a neuro-oncologist, is deeply embedded in these technologies, these big data sources of looking from the end backwards. Yeah, Barnes Jewish is on the forefront.
Okay, and then on the other side is the creative side. So I'm a huge fan of history. And so when you look at cities like St. Louis, we have this vast amount of history that people don't understand. I mean, do you see the world where we go to Scott Joplin's house and we watch Scott Joplin actually play in his house? Or we walk down Washington Avenue and we watch the battle during the Civil War where Missouri fought for the right for St. Louis to stay northern versus southern, and you watch those people actually take on. Or you go to a cemetery and you see the people in the cemetery by localizing on their gravestone, and you see their life experiences. Is that the kind of stuff that you're working on, and do you see that world coming?
Yeah, all that stuff that you're talking about is completely feasible and doable right now, and there are companies that are doing field trips out to, virtual field trips to the pyramids and walking through some of the tombs in Egypt and able to actually, put on a headset and interact with that space. So yeah, I mean, everything that you said, by the way, if you're ever looking for a job in creativity and like coming up with ideas for AR, VR, let me know. But yeah, those are awesome ideas. I think this is kind of back to that content barrier that we're talking about, is like, there is a data gap and us understanding everything that went on and how it went on and where it went on exactly to be able to represent that perfectly. And then you have to create, like, because this is so immersive, you have the visuals, you have everything. But yeah, that's everything that you mentioned is absolutely doable right now, and there are companies that are doing very similar apps, including ourselves. So. Yeah, happy to.
One quick remark before our next question is, I think we can combine both of your questions together. So on the first topic of, can we use VR and the metaverse as a medical intervention? I think the answer is that in many cases we can. The VR experiences have recently been listed by the FDA as a drug-like intervention that can be used in clinical therapeutics. And if you think about something like being on the autism spectrum, for instance, we know that one brain mechanism that could use a hand for people with that syndrome is a theory of mind-related mechanism. So the ability that we have to make inferences about each other's mental states. And one of the key parts of that mechanism is our ability to look at and track each other's eyes, right? So that's why joint attention and things like ball throwing are so much fun for a parent and a child. And so if it turns out that that brain mechanism is plastic, and all we need to do is provision the right set of experiences to retrain that brain, then we can do it. And there is some evidence that those kind of VR interventions work even for things like eye gaze-centered theory of mind inference for individuals with Asperger's. Now, that connects to your second question. I think of the metaverse as one huge experience provisioning machine. How does training and education happen? With the provisioning of experience. If we can use those same kinds of technologies to build adaptive models for things like training and education, as I know Brad has done, then we're off to the races in using the power of the metaverse to kind of change our brains in a way that helps us do the things we want to do more quickly. And to get that very practical upshot, think of like a warfighter, somebody doing something that requires sensory, the integration of multiple sensory modalities, like you were seeing in that last film clip on my final slide, our first-person shooter scenario. There are well-known mechanisms in the brain that are responsible for things like attentional allocation. In fact, there's a model of attentional allocation that somebody called Broadbent put together, and it postulates that there's basically a funnel, a bottleneck of attention that is modality specific. So what that tells me is if I can model that soldier's Broadbent bottleneck, then I will know that next written alert I issue to them that they're about to miss an adversary who's going to hurt them, right? I should provide to them auditorily rather than visually if the visual modality is overloaded. So the metaverse can help us both operationally, right, in these point instances of improving performance, but also by provisioning experiences in general in a way that retrains our brains to allow us to be to get done what we want to do.
The concept of conscious and subconscious that you brought up, I mean, that is brilliant. Like, our body's taken so much information which we then dream about, and I think everyone can express our dreams sometimes are crazy, and you're like, why did I even dream that? It's that stimulus that happens, and the fact in the metaverse, everyone kind of views video games as evil, like, our kids are playing it too much, it's overstimulation. But there's so much that you could do on a conscious and subconscious level, I think, that would be very rewarding for people. So let's stop there.
Yeah, I mean, if you look cognitively, if you look at the neurotransmitters in the brain, experiences will lead to changes in neurotransmitters. Imagine that an experience can lead to a chemical change. It's like a drug, right? So you take someone with PTSD. These people are not crazy. They had an experience that led to something that was god-awful, and it led to a neurochemical imbalance. That experiential learning can change. You take, I saw a show briefly about Chris Helmsworth overcoming his fear of heights. So he went into virtual reality. He went out on a boom that was 3,000 feet over the city of Sydney and felt what that was like. And then went that in the metaverse, understood what those feelings of fear and dread and doom were like, and then he took that into the real world and went out on the boom 5,000 feet over the city of however it was. I mean, it's incredible. So experiences absolutely lead to neurochemical changes in our brain. I mean, there's no question. So a memory can be a drug. It has to be. And so an experience in the metaverse can absolutely lead us to wisdom. It can lead us to conquering fear or anxiety, or absolutely. So I think there's a great place in our field for this, just experientially. We just have to have the sensory input get closer to reality. It can't just be a game where we're seeing things. We have to have a better appreciation of all the senses for us to do that.
Okay, I have a more simple question. What developments and changes do you guys see and or what are you most excited for? Not just in your field, but in general? For all of you.
I'm excited for miniaturization, implantable sensors, wearable technology, and finding new problems to use this technology for. I think we just have to direct it at some place. You talk about experiential learning. We were in Bath in England, and Bill Bryson was talking. We could see him in our VR scope. That you just take the desire and the funds and you point it in the right direction. In the medical field, it's where is the need, of course, and knowing that things like autism. Autism, I believe, is something that will be treated experientially. Understanding, that we're all made differently. Some of us are oral, some of us are sensory, some of us are visual learners. Anybody who's taken a Briggs-Meyer personality test understands that all of our brains are made differently. When our son realized that his learning technique was more auditory than visual, his dyslexia didn't matter. Knowledge is power. So it's understanding ourselves and how we can use what we were given in the best possible way.
Yeah, I think what I'm most excited about is the mass adoption of these wearables and getting them to a consumer-ready standpoint. So there are so much technology out there surrounding these fields, specifically in virtual, and how to immerse people into these events, whether they're training or real-life experiences, that you can see have very positive impacts among communities and culture and people in general, whether that's a personal training or a city, making real city difference. We're still sort of in we've passed the strictly gimmicky experiences, and now we're into a beneficial experiences with some gimmick aspect to it, kind of faking some of the things that we really want to do but we can't quite yet. And I'm excited for the time where these products become consumer friendly, mass adoptable, and then you can actually take that and make them into real life-changing experiences and products. I think that we'll see going along the lines of the dangerous jobs and heights, like we were talking about, really seeing people know how to do things properly so that whenever they are performing those tasks, they're at their safest. And also just things that we don't even know because we can't visualize this data that will benefit cities and cultures and kind of alleviate a lot of the issues that we're having. I think the technology and that being adopted from a mass standpoint will definitely solve some of those issues. So.
Yeah, I'm excited to see how this group of technologies is applied in unexpected ways to help us make more sense of the world. Right, so we can improve it. And I think that these tools and the type of data collection that happens in geospatial and other forms of intelligence can be a huge boon for our scientific understanding of our place in the universe and help us do things like build a closed loop medical therapeutic VR system. So turn these technologies loose, creative, talented, motivated people, see what happens. I'm pumped about that. We're in the last couple of minutes of our panel, so let's, before we break and mingle, so let's see what last couple of questions we have before we have drinks together and talk more.
Do we have any other questions?
First of all, great presentations, everybody. You had mentioned about your interest in doing augmented reality type displays and stuff. Have you talked to the CENTIAR people? It's another WashU spinoff, Arch Grants winner 2017. You don't know. You need to Google them because they CENTIAR, SENTIAR, all caps. Yes, you should talk to them. They've raised about 15 mil. They're doing. I don't know. I've lost touch since the pandemic, but I think they're doing okay.
But the thing that Brad said is most valuable is the presentations are nice, but what I really get geeked on is when I'm in his lab, when he's in my operating room, when I'm at the console, and just understanding the tools that are available. Even when I go to another surgical subspecialist operating room, we don't really talk to each other that much. So when I see what a neurotologist uses or a cardiothoracic surgeon uses, the light bulbs just go off in my head. And so cross-experiential learning is so valuable. And so I would love to have someone like you in my operating room, and I'd love to be in your workspaces.
Not on the table.
No. Yeah, and those kinds of things are really what's going to lead us to really collaborate. This is good and fun, and it's turning on light bulbs. But being in each other's world, speaking each other's language, that's the crucial thing. I'm a navigator, right? I take someone on that path from A to B, but to see what it takes to do that will clearly forward all of our knowledge bases because we live in different worlds. When you put up that initial, what was it? Something PED? BC PED. You were speaking a language that clearly most in the room. I look over at Brad. I'm like, what does that stand for? So yeah,
my answer was I don't know. You don't have to say
exactly. Brad said he didn't know this.
Say it out loud.
Yeah. But we really do live in different worlds.
Know what most of the acronyms mean.
Exactly. So yeah, I think the more we can be in each other's worlds, the more we'll speak, the more we'll learn, and forward, everything will go together. This is. I hope you've enjoyed it. I've enjoyed this incredibly, just because this is mind-opening.
Okay, Bill, before you wrap up real quick, I'd like to thank Adam from Project Geospatial for podcasting this out for everyone tonight that's not here in the room.
Excellent.
Thank you, Adam. I'd also like to thank each of you panel members for taking time out of your lives to come here and talk to us today, incredibly, as to the insight and your thoughts and everything that you've got going on. So a round for these guys.
Thanks very much, Todd. No conclusion necessary. Please mingle, talk to our speakers, and I look forward to moving from the maps to the metaverse with you all. Thank you for your attendance tonight.